Hi, today I'd like to talk about finding the internal angles of a tetrahedron. A tetrahedron is one of the regular solids. It has four identical sides, each of which is an equilateral triangle, as depicted here. And it can also be shown as a methane molecule with each vertex being occupied by a hydrogen atom with a carbon atom at the center. And the angle between the molecular bonds, all of which are equal, is essentially the angle that we're trying to find. Just to start off with, we're going to make it easier for ourselves by making each of the edges of this tetrahedron be equal to 1. And so now we're going to look at one of the faces, which, as we said before, is an equilateral triangle. Has a face of 1. So now if I cut that in half, we'll know that that is 1/2, and we'll use the Pythagorean theorem. So 1 minus 1/2 squared, which is 1 minus a quarter, is 3/4. Take the square root of that, and that's going to be the square root of 3/2 is the height. So we know that now if I were to cut that there, we know that that is equal to the square root of 3/2. And same with the bottom side that's resting on the surface. That's square root of 3/2. So let's go ahead and take a different look at it. We're going to assume we're going to open it up and look at the cross section. Okay, so now, although this is not very accurately drawn, we'll look at the cross section. We'll say that this side is equal to 1. That's this side right here, and this line right here, that's this one, which is a square root of 3/2, and this at the bottom is also square root of 3/2. So now I will draw a line that intersects this bottom at a right angle, and I'll do the same for the other side. And those are right angles. Now the angle which we're going to find, which is alpha, is this angle right here. Okay, so a carbon will be sitting right here as shown here. So now I know that this angle here belongs to both this triangle as well as that bigger triangle. And so we know now that this angle, they both share that angle, and they both share a right angle, which means then that this angle and this angle must be equal. And mind you, this angle is 180 minus the angle which we're looking for. So now with that in mind, let's go ahead and consider the height of this to be y. I will call this side x, and this side here is the square root of 3/2 minus x. And so now we can say now that x squared plus y squared is equal to square root of 3/2 squared, which we know is 3/4. So we can say now x squared plus y squared is equal to 3/4. We can say now also the square root of 3/2 minus square root of 3 divided by 2 minus x squared plus y squared is equal to 1. Okay, so now we can say now that 3/4 minus, well, 2 times this is just the square root of 3 times negative x, so minus the square root of 3 times x plus x squared plus y squared is equal to 1, minus the first equation from second, which is minus x squared minus y squared is equal to minus 3/4. So we know these numbers here cancel, and so we can say now 3/4 minus square root of 3 times x is equal to 1 minus 3/4, which is 1/4. Okay, so now if I minus 3/4 from both sides, I'll get minus square root of 3 times x is equal to minus 1/2, which means, okay, there's a minus sign there, which means that now x is equal to 1 over 2 times the square root of 3. So that's 1 over 2 times the square root of 3. So now, if x is equal to 1 over 2 times the square root of 3, well, we know that this length divided by that length is the cosine of this angle. So we can say now, and mind you, this angle is 180 degrees minus alpha. So we can say cosine of 180 minus alpha is equal to 1 over 2 times the square root of 3 times, well, I'm just going to multiply by the reciprocal of that, which is 2 over the square root of 3, which is equal to 1 over 3. So cosine of 180 minus alpha is equal to 1 over 3, which means 180 minus alpha is equal to arc cosine 1 over third, which is approximately equal to about 70.5 degrees. Which means then now, if 180 minus alpha is 70.5 degrees, we can say alpha is approximately equal to 109.5 degrees. So that is how we find the internal angles of the tetrahedron. I hope you find this informative, and I'd like to thank you very much for watching.